Hi everyone. Now that we're done all the different types of molecules and their reactions, there's this other slightly different category of molecules that we use every day. Here's one example. Here's another example, my shirt. Are called polymers. Man-made polymers, but also natural polymers. Our hair is a natural polymer, and there are many natural polymers um, in our bodies. And but yeah, we'll talk mostly about man-made polymers in this section. So for most of you this year, hopefully later years, this will be fixed. I still had addition polymers earlier in the textbook, and I said we'd come back to it later. So I think it's page 17 with alkanes and alkenes. It does fit there as well, but we can talk about them all together. So polymers are plastics. You use them all the time. And the first kind of polymer, addition polymer, undergoes an addition reaction. So it's always based around 2 carbons. So because of this addition reaction, the double bond, then when it opens up, it can add 2 things. Often we were putting those on the top or the bottom, but here we'll imagine those 2 new things are on the sides. So polypropylene, prop 3 carbons. The monomer, the one thing that it's formed from, is propene. So the part that's going to be repeating and bonding to itself are just those 2 carbons. 2 carbons, 2 carbons, 2 carbons. If you get that, this is so easy. So I'll move that CH3 that was on the right side to the top. And what that does, it allows me to put the bond on the side and to bond another one. And this is what polymers are. They are long, long units of often a repeating unit, making a really long one. And that's why we get all these amazing materials like the plastic in my pen, like plastic bags, like ropes, cards like your bus card or your credit card or your bank card are made of polypropylene. Teflon is a really cool one. It just has fluorines all around that double bonded carbon. So the polymer, there's one repeating unit, add another repeating unit, and it just carries on. So notice that I have included the bonds on the side to show that it doesn't stop. It keeps bonding. Sometimes you'll see it written like this, N, meaning repeating many times. Teflon is used in non-stick pots. They are amazing. And we don't really have time to talk about this in chemistry. We'll just be looking at the chemical structure of polymers and plastics. They are amazing. They can make so many different things. But the other side of that is the environmental side, which I'm sure many of you will be very concerned about and know about. I'm sorry, we won't really be talking about it, but don't worry, I know. Yes, one side is amazing. The other side, we have too much. What are we going to do with all of this? Chemists will be involved in finding the solution for that. How can we recycle it? Can we recycle it without spending too much money? All of those things include knowing about the chemical structure. So there are a few more here. The only difference is what's on the side. What is that side group? And they're all 2 carbon unit base, but by having different things on the side, then they have different properties. All right, so maybe I'll get you to try some when I see you. The key there, those keywords monomer and polymer. And we will see these again in the other kind of polymer as well. These are condensation polymers, and they're called condensation polymers because they're formed by condensation reaction. So that is later in your study guide. So as long as it's formed by a condensation reaction, it would be considered a condensation polymer. There are actually many of these, but since we've learned about making an ester through condensation reaction and making an amide, we'll look at polyesters and polyamides, and that's a really good starting place. So polyesters are linked by an ester group. So there'll be that ester group somewhere in the middle. That would be the linking group. And there can be one monomer or two monomers. Two monomers is quite common, but I'll give you one example of each. Don't need to memorize any of these examples, but if I give you the monomer, I will ask you to write the polymer for me, or if I give you the polymer, then be able to see from that what was the monomer. So this one's called PET. Here are the two monomers. So one of them, when there are two monomers, one monomer will have the same functional group on two sides. So this is a diacid. The other one will have an alcohol group on two sides to make a polyester. So this is a dialcohol. And when they react together, then they form a repeating each part again and again and again. So that would be the repeating unit, one repeating unit of PET. And PET is used in the polyester in my shirt that I'm wearing. It's used in many water bottles. We use a lot of PET in this world. You might think it's funny that this polyester is actually the same material as what we use in the water bottle, but they just process it slightly differently. So here's another example that would make a polyester, but this one has two different functional groups on the same molecule, but it will add to itself then to make the polymer. And then that would add bond to an oxygen on the next molecule. That whole thing, C double bond O, would bond to the oxygen on the next molecule. You end up with a very long molecule, and it has many of the properties we're familiar with of plastics. This one is polylactic acid. Some of you might recognize that as being part of milk, and so it is one of the new-ish polymers that are biodegradable, that do not last forever. And it may be not the best one, but this goes to show there's lots of research and lots of jobs out there for new students like you. All right, so the last one I'll look at today, the man-made polymer, polyamides. So for these ones, the linking group will be an amide group. This is the same amide we saw earlier. I hope it's okay. It doesn't matter which way you draw it. Okay, if you put the N on the left side and the C double bond O on the right side, that does not matter. But I'll give you two examples. Both of them actually have two monomers. So here I've written an acid chloride as the functional group on this other monomer, the acid monomer. It could be acid or acid chloride. They can do it under special conditions and get it to react as an acid as well, but I don't know. So when you're writing it, you could write it either way. Same thing here. If you wrote an acid chloride instead of one of these acids, that would be, except, although they should be the same. If it's acid chloride, they should both be acid chloride. And like condensation reactions we saw before, always a hydrogen and a Cl are lost to make a small molecule HCl lost when it's an acid chloride. When it's an acid, it would be water. There is one repeating unit of nylon 6,6. It's called nylon 6,6 because there are 6 carbons here, and there are 6 carbons. Oops, now there are 6 carbons here. And there are different forms of nylon, nylon 610, nylon 1010, but nylon is, you definitely have used it in your lives. It is used for those very strong straps on your backpack. It is used in ropes. It is used for parachute. Maybe you've gone parachuting, I don't know. But it's a very strong light material. I'll do this one the opposite way. I'll show you the polymer first and hopefully show you how you would get to the monomers if the question gives you the polymer. Okay, here is a section of the polymer. So what you need to look for is that linking group and then the two parts of that. So from one part of the functional group, acid or acid chloride to acid, and then the other part nitrogen to nitrogen. So I've intentionally added a little bit more here to show you that you need to decide where to stop and when to stop. And here I've added OH to make it into an acid group. Doesn't matter. I don't actually know. I'm sure different manufacturers use slightly different chemicals. And there now also has to be 2 hydrogens on that nitrogen after it has been split into the 2 parts. Kevlar is very, very strong and hard. It's used in body armor for soldiers. It's used in tires to stop them from getting holes in them when you drive over glass on the road, bicycle tires and car tires. It is very, very strong and hard. And it has this weird functional group. I know we haven't learned this. This is benzene. Don't have to know how to name it. But if you see it here, just copy it. But it is fairly common. So those are the main types of man-made polymers: synthetic polymers, addition polymers, polyesters, and polyamides. And we'll look at some natural polymers in the next video and do some practice together. And you can ask any questions when I see you. Bye-bye.